now let us see the effect of variation of temperature on the time period of simple pendulum. Seconds pendulum. Simple pendulum whose time period is 2 seconds is called seconds pendulum. So, we have a pendulum here. So, when suppose the pendulum is at this stage, so it takes 1 second to reach here and then again it takes 1 second. So, when the time period is 2 seconds, it is called seconds pendulum. So, first of all let us do some general analysis. So, this length is L suppose. So, consider a simple pendulum of length L. So, its time period is given by 2 pi root over L by G. If I take T square, it will be 4 pi square L by G. Now, if I differentiate it, I will get 2T dt is equal to 4 pi square by G dl. I assume that the G does not change, but the length may be changing due to some reasons. Here I am interested in the length change due to changes in the temperature of the system. So, we can write 2T dt by, let us see what is this quantity, 4 pi square by G is again T square by L. So, we have 1T, then we have dt by T is equal to half dl by L. This is one relation which relates how time period is going to be affected if there is a change in length. Now, with change in temperature, the length also changes. So, how it is changes? So, the length, change in length dl is equal to initial length L into alpha into d theta, where d theta is the rise in temperature, or theta, if you write theta, then it will be theta is the rise in temperature, change in temperature denoted by theta. So, this is equation 2. So, from 1 and 2 we get, so dt by t, that is half, dl by L is alpha theta. So, thus the fractional change in the time period of a simple pendulum that is dt by t is half alpha theta. So, dt by t, that is half alpha theta, is the change in time per second. This is fractional change. So, per unit time the change is half alpha theta. Per oscillation for a seconds pendulum, t value is 2, will be alpha theta. Now, when the temperature rises, then the length of the simple pendulum increases, and so the time period also increases. So, we have time period t is equal to 2 pi root over L by G. So, length increases, time period also increases. Thus it takes longer time for the pendulum to complete a oscillation. As a result, it takes longer time. So, actually we think that it is 2 seconds, but actually it is 2.5 seconds, taking time to show 2 seconds. So, as a result, the clock slows down. slows down. So, when temperature rises, the clock slows down. So, temperature rises, clock slows. Temperature decreases, clock gains time. So, thus you see how to relate. Temperature rises, summer, clock slows down. Pendulum clock, temperature decreases, winter season, clocks gains time. Thus, the total gain or loss in time per day is half alpha theta into 86400. This per second, this is the loss or gain of time. In a day there are 86400 seconds. So, this much time is lost or gained by a simple pendulum, seconds pendulum per day. Now, let us take an example to see how clock slows down. So, a clock becomes fast by t1 seconds when the temperature of the room is theta 1 and runs slow by t2 seconds when the temperature of the room is theta 2 in a day. That means this is in a per day, the time it is gaining is T1 and the time T2 it loses when the temperature is theta 2 is T2. So, find at what temperature the clock shows correct. So, there is no loss and gain of time at what temperature. So, you see here when the room temperature is theta 1, it becomes fast by T1. So, this room has a temperature. So, this is cold room where it is becoming fast by T1 second. It is gaining time by T1 seconds. So, and when the temperature is, so when temperature is increased, then temperature is theta 2, then that is hot, that means the length is more, and so it slows down, and in a day it slows down by T2. So, suppose the room temperature, so this is ambient temperature, that should be theta, at which the clock runs as usual, shows the correct time. So, we have to determine this. So, when it is hot, then the temperature is T2, that is half alpha theta into 86400. So, this is T2. So, that is T2 will be equal to half. Alpha is the coefficient of linear expansion of the pendulum, and the temperature it is increased is theta 2 minus theta, and this is 86400. This is equation number 1. For this case, T1 will be equal to half again alpha. This is cold here. The length is decreased. So, theta minus theta 1, that is 86400. So, this is equation number 2. Now, with the help of these two equations, we can determine theta, and so from 1 and 2, so from 1 and 2 we get theta is equal to something. So, thus you see by solving these two we can get theta. So, in exam you will get problems at a particular temperature it loses time, at a particular temperature it gains time. So, what is the temperature at which the clock shows the correct reading. So, this is the procedure we have to adopt.